future is not as bad as it seems, and I swear I will be patient, they told me. But I know that people always prejudice. Still my dark inside is me just like us. This is just a riptide. Don't want to be broken, 'cause I still keep hoping. Just like us.
Shall we? Hello? Well, good evening and welcome to everybody. Can you hear me? Is it good? All right, let's try that again. Good evening, welcome. I'm Anthony Toriani. I'm from Monaco Asset Management. I'd like to welcome you all here. I think these MMF talks are really a great, valuable civic service provided to Monaco. We get to listen, get enlightened by a variety of interesting, eclectic, and eminent speakers. And I think the significant attendance we have tonight and the significant attendance we have at these events, on most of our events, they demonstrate that there is a utility, there is a great service, and I think tonight will be no exception. We have a fantastic speaker for you here tonight again. So at Monaco Asset Management, we're delighted to sponsor these MMF speeches. We are joined by our co-sponsors, Juto Husson with Hervé Husson, JB Pastor, Madame Pastor, and of course the SPM, so thank you to all of them. And especially thank you to the president of MMF, Sandra Braggiotti, who never tires in her energy and devotion, and who never stops asking me to make these introductions. So it does give me an immense pleasure to be here introducing a remarkable individual in Dr. Alon Chen, and to have him present the Weizmann Institute, one of the preeminent multidisciplinary scientific institutes in the world. I think we're all aware there's a multitude of serious issues, serious political and social upheaval plaguing the world today, including the appalling events in Israel itself and in many other areas around the world. So for once, it's a pleasure not to be talking about the problem, but to be talking about the solution. And I think, the Weizmann Institute and its work is one of the big parts of the solution to all of these issues that we face. I think most of us can acknowledge that education, science, and knowledge are the best antidotes to radicalism, belligerence, propaganda, and fear-mongering. And I think Dr. Chen and the Weizmann Institute are shining examples of a dedication to the advancement of science for the benefit of humanity. They give us hope that through these efforts, we will successfully tackle some of these daunting issues. So to Dr. Chen, and I'm sorry, I'm going to be a little long because his accomplishments are so broad. He's a neuroscientist, he's a professor, he's an entrepreneur, and just as significantly, he's a vocal proponent of the importance of science and its pivotal role in decision-making and in society in general. So after a BSc, an MBA, and a PhD, of course, all magna cum laude, at some of the most prestigious entities in Israel, including the Weizmann Institute. He finished his education at the Salk Institute in California with a postdoctoral as a Fulbright scholar. He's an adjunct professor of medicine at Ludwig Maximilian University in Germany, director of the Max Planck Institute of Psychiatry. And as I said, I haven't even begun to scratch the surface because he has plenty of other accomplishments. His specialization as a neuropsychiatrist is on biological processes that regulate and activate stress, and the mechanisms connected to anxiety, depression, eating disorders, metabolic syndromes, and he's very widely published in his field. Dr. Chen was appointed as a senior scientist in neurobiology at the Weizmann Institute in 2005, the head of neurology in 2013, and finally the 11th president of the Weizmann Institute. I think it speaks to the importance that the nation of Israel has attached to science and education, that the Weizmann Institute of Science, founded 90 years ago as the Seif Institute, was renamed in 1949, 2 years after independence, and was and welcomed as its first president, Chaim Weizmann, also the first president of the nation of Israel. It's renowned for its cutting-edge research and has fostered multitudes of important medications, innovative technologies, and successful startup companies. Probably more important, the Institute has educated a legion of current and former students and faculty who continue to improve the world we live in with immense talents and scientific achievements. So I'd love to welcome Dr. Chen to tell us more about the Weizmann Institute.
Thank you, Tony, very much for this very kind introduction, and good evening, good afternoon, everyone. Many thanks to Sandra Raggiotti for this kind invitation, the chairwoman of the MMF, and of course, Januka, where are you, for hosting me and for organizing this, and Marco Dueck for making this contact, and of course, all of you for coming tonight. As Tony mentioned, I'm a neuroscientist, and we will need to find another option to talk about stress and how it's affecting your health. I love talking about stress, so maybe Marco heard me multiple times, and so I can talk about science. I will mention brain sciences because this is one of the focus of the Weizmann Institute, but I mainly would like to talk today about excellence, about science, about curiosity-driven, hi Jonathan, curiosity-driven research, and using the Weizmann, of course, as a model, okay? I want you to understand the importance of science to humanity, and especially during these challenging days. So I will share with you our philosophy, and Tony mentioned that the Weizmann was already established in 1934 as the ZIF, and Jonathan here is actually part of this distinguished family, which is 14 years before the State of Israel. And actually Israel is a very unique example of a country which at least three major universities, research institutions, the Hebrew University in Jerusalem, the Technion in Haifa, and the Weizmann were established 2 to 3 decades before the State of Israel, which was the vision. In order to build a country, you need the engineers, you need the scientists, you need the clinicians that will be able to get this country and make it. And Israel is a very good example of this success. So and Tony also mentioned this, already in 1949, as recognition and honoring the activity of Dr. Chaim Weizmann, the name has been changed to the Weizmann Institute, but we're actually celebrating 90 years this year. And today, from this one building, which is now preserved as our heritage center, now we have almost 270 buildings sitting on almost 1,000 acres and still going. And this will give you some, let's see if this video will work. Oh, yeah, now it's working. Oh, why you don't see the presentation there? You saw it before? Okay, so it's jumping between me. So this is just an eye-bird view of this really beautiful campus. And there is a reason why it's so beautiful and welcoming, very green, because we are a community. And I would like to share with you this part and this philosophy. So what is the Weizmann? What makes the Weizmann such as a unique place? And I just had an interview, both a newspaper and a TV interview, and they asked me, what is the Weizmann mission? Why we wake up every morning? And we wake up for only one reason, okay? We do what we do in order to generate fundamental knowledge. We are in the knowledge business. We create knowledge, but major, fundamental knowledge, not to the benefit of the Weizmann although as you will see, we benefit, of course, from this, and not to the benefit of State of Israel, although they benefit from this, but for the benefit and for the future of humanity. This is the definition. It's not a slogan. We do what we do in order to eventually solve problem and create knowledge that benefit the humanity in general. So the philosophy is very different, and I had the privilege to work in at least two major leading research institutions. One of them, Tony mentioned, is the Salk Institute in San Diego, in La Jolla, and the second one for 7 years at the Max Planck Institute in Germany. So they are both research institutions, but the philosophy and the approach is a bit different. Israel is a very small country, so what we do, it's very simple. We invest in people. We do everything possible to recruit the most outstanding scientists, the most outstanding people. We don't even ask them what they are working on or what they are focusing, as long as they are within our field of interest, which is exact and natural sciences, meaning we are covering the entire fields of biomedical life science and biomedical research, chemistry, physics, math, and computer science, okay? And everything in between, and this is very important, and I will mention this interdisciplinarity because I think it's an important factor. So we recruit the most outstanding scientists we can recruit, and then we do everything to provide them with the best infrastructure, meaning the best laboratories, the best equipment, the best environment, and then we give them full academic freedom, okay? We want them to go with their dream, with their passion. We really want them to dare, okay, to break dogmas, to ask very big questions, and as we call it, to think and do beyond the state of the art that is currently done worldwide. So I mentioned we give them the best tool and so on. Two very unique features, in addition to this full freedom they have, is this interdisciplinarity that I mentioned. So we have 5 faculties, 19 departments, but we really try to keep them, or the borders between them, quite permeable, meaning we want people that were trained or grew up in physics, we want them to work on cancer. And people who are trained in AI, math, computer science, we want them to work on chemistry or astrophysics. And the reason is that most of the biggest challenges that humanity have today, whether they are biomedical challenges or environmental challenges, they are so complex that we need experts coming from totally different fields. I'm a neuroscientist, I'm coming from the biomedical area. The brain is such a complex organ, and I will talk about it in a minute, but it's not enough to have people who are coming from life sciences or medicine. We need people who come from math, computer science, people who understand AI. We need people who understand chemistry and psychology and physics, and we need to bring them all together to interact. And then this is probably the most unique feature of the Weizmann. I don't know if you can see it from above. People like Marco or Jonathan who visited Weizmann know this, that most of our scientists live on campus. Okay, so it's a gated community. We do everything to provide our scientists everything they need in order not to go outside. Okay, unless you go to the airport, you should stay. So they have the housing. We provide the housing. We provide the daycare from the kids from 3 months of age until preschool. We have the gym and the swimming pool and the theater and the grocery store. But why it's part of the philosophy? It's part of the philosophy because me as a neuroscientist, all day I'm in my neuroscientist environment, so I'm meeting only brain people, and we talk about the brain. But when I'm going back home and I'm taking my children to the playground, it used to be, now they're big, but when they were young, I'm going to meet other scientists. They are from physics and they are from math, and they are with me on the building complex. I don't see them during the day many times because they are not in my area on campus, so it's a big campus. But in the evening, even when I'm going to throw in my trash, I'm going to meet someone. And we're going to talk about projects, and we're going to develop and think about collaborations and so on. So this is a major part of our philosophy. So eventually, it's all about excellence. Okay, this is the singular criteria. To become a scientist at the Weizmann, the only criteria is excellence. I even take it further. Now, we all agree it's important to solve the problem of Alzheimer's. We will not proactively go and look for the best Alzheimer's scientists in the world. We don't do it. Why? You know, maybe if you live in Monaco, you live in Munich, Boston, or it's easy because you can convince people to come. When you live in a country, Israel, which is a beautiful country, those of you who didn't visit it, but still complicated neighborhood, I would say. Not every scientist who don't have a link or connection to Israel or family will necessarily come. So we invest in talent, we invest in excellence. So if, I don't know, Sandra is an expert in a very rare green lizard in the Amazon, as long as Sandra is the most outstanding, the best in the world in green lizard, we would like to get her. And we're going to build for her a farm of green lizard and let you lead, because this is basic science. And I will give you a few examples. Eventually, basic science is the source of all knowledge. And Weizmann is probably the best example of how basic science can be translated eventually to new medications, to new devices, and I will give you a few examples of how we do this type of tech transfer. So I mentioned already that we're focusing on people. So just to give you a few more numbers, okay, Weizmann currently have all over 4,500 people. We have 270 research groups, okay, led by different professors from the different fields. We are not university, okay? We don't have undergraduates. We don't have first degree or bachelor. We have only master, PhD, postdoctoral fellows, around 2,200 students and postdoc, and it's a very, very international, okay? The formal language is English. 70% of our postdoctoral fellows are international. 30% of our students are international. We don't have tuition, okay? No one is paying to study at the Weizmann, and everyone is getting scholarship and fellowship. Actually, I visited today, together with Gianluca, the scientific, what would be the right term in? Yeah, you heard? The scientific center here in Monaco, which is beautiful, very strong marine biology. I don't know if he's with us here tonight. Oh, the team is right here. Thank you. The director, he did his postdoctoral training at the Weizmann, so great privilege, just one example, great example of this. As you can see here, Weizmann is, just last year, every year we publish more than 3,100 studies, and at the end I will share with you a few of those recent findings just from the last year and few months, and of course we eventually produce 25% of all the PhDs in natural and exact sciences in the state of Israel. So there is a huge impact on economy, on society in general, and I think which is also beyond the state of Israel. I want to say something about the role of science in general in building resilience, okay, and building resilience for societies, for countries, and I think it was very clear during pandemic, not everywhere, but I think the public eventually understood the importance of science in finding solutions to this disease. We have so many environmental challenges currently and other biomedical challenges. I think Weizmann is a great example for this, but it's also a great institution worldwide, eventually creating a knowledge, what we call a knowledge-based society. It's something that is critical for productive country and a resilient society. Science cannot be done in a silo, okay? Scientists, and we have scientists here also in the audience, science is extremely collaborative. Weizmann, and I will show you, one slide in a minute on institutions that we collaborate. But it's integral part of science. You're all following what's going on now in Israel and worldwide. There is, I don't know how many of you exposed to this hearing in the Congress for the presidents of Harvard and UPenn and MIT, which was ridiculous. But we have ongoing collaboration. We have full program with MIT and Harvard. I sent very tough letters to all these presidents. Some of you read this. But doesn't mean we interfere with the collaboration of the scientists, because eventually scientists would love to work together and interact. So you cannot work in a silo. So science has a very important role in relationships. But it's more than that. And countries that need security or defense, talking about the Weizmann, definitely major contribution to cryptography and quantum computing. Weizmann last year announced the first Israel quantum computer, one of 30 in the world, developed at the Weizmann. Productivity, yeah. Science eventually is a driving force for jobs and definitely products, and I will give you a few examples. For human health, major part, almost 50% of the work we do eventually contribute to the quality of life and solving disease-related, and I will give you a few examples for the planet. Major challenges we are facing today are the environment. We talked today a little bit during my visit, but solutions. We need to find solution. Either it's going to food security or pollutions or global warming or many other. Jonathan here is working on biodegradable plastic, which is unbelievable and very much needed. And of course, informed society. And the Weizmann, in addition to the fact that we do basic science and we give back to society by making knowledge and producing new solutions, new medication, new algorithms, we also care about the next generation. So we invest a lot in trying to educate both the public and mainly the children. So the Weizmann have an educational arm. It's called the Weizmann Institute. In Israel, everyone knows what the Weizmann Institute is, and I think slowly more people abroad will try to recognize and will understand. But this is our educational arm, okay? We have more than 70, 80 programs from third grade all the way to teacher training. If you go to the website, you will see it's in English, in French, in Deutsch, in German, in Spanish, in Portuguese. And the idea is to take the findings, not only from the Weizmann, from all over the world. We don't need to wait 2, 3, 4, 5 years until it's in the textbook. We want our children, we want our teachers to know the latest discoveries and teach them for the rest. So Israel is a very small country, yeah? 9 million plus minus every year. We host between 300,000 to 400,000 people coming, families, children, teachers going through the Weizmann every year. Usually I don't like to talk about ranking and awards, and there's the reason I didn't list them here, but eventually you need somehow to evaluate the impact that your science is doing. There are different ways to do it. I'm not going to talk about the budget and so on, but you should know that major part of our budget, the way we eventually sponsor, is coming directly from our scientists. If you choose the best scientists, they're also more successful in obtaining research grants. And Israel, luckily, we are part of the EU in science, so our scientists can apply to the EU. And you should know that in the EU, the success rate when you send a grant is around 11%. Okay, every 1 to 10 grant is eventually funded by the EU. The Weizmann success rate in the EU is 55%. Okay, so which is 5 times higher than the average European, which again says something about the quality of this. And if you assess the impact of the work on society. It's called Leiden ranking, which really, and you have scientists here who is citing eventually your work. You will see that Weizmann will be the only institution outside of the US which will be ranked on the top 10, 7, 8, 9, for many, many, many years, when you really assess the impact of the science. And of course, we don't do this for this recognition. We do it just in order to assess our own science and quality. So I want to talk a little bit about the innovation ecosystem. I told you we are a non-profit organization. Okay, we do what we do eventually in order to create knowledge and to use it for the benefit of humanity. However, we generate a lot of knowledge and we do basic fundamental science. Nevertheless, some of this knowledge have relevance for disease, for solution, for devices. So actually only a small part of it eventually is protected, meaning it's patented and commercialized. Weizmann have one of the first, actually the second worldwide tech transfer office, 1959. Okay, the first one was University of Wisconsin. We don't know why, it was never successful. And since then, it actually was part of the vision of Chaim Weizmann. They take the knowledge for the benefit of humanity. And although this is not the focus, and you will see most of the treatments, the drugs, and I will show you a list, you will see that this was not the aim. The aim was to understand mechanisms, why our body is working the way it is, why the brain, why the environment, understand processes and mechanisms and so on. So within this ecosystem, we had a daughter company called Yeda, never mind, which means knowledge in Hebrew, and they're responsible for protecting the knowledge, commercializing this. We don't do it within the Weizmann, okay? We do it outside, and this is just a partial list of blockbuster drugs that were developed at the Weizmann in the last few decades. This is $1 billion drugs that eventually benefited the world, many, and also, of course, benefited the Weizmann because it allows us to support the science. A lot of this support is going back to the science and, of course, to the scientists who develop them. I talked about collaborations. We have many, many collaborations. I just listed some of them here just to show and demonstrate how important science is in connecting people, okay, in connecting societies. Many of the biggest projects worldwide, and I told a few of the colleagues earlier today that from here I'm going to the US, but then I'm going to Chile. So why Chile? Because Chile is amazing site for astrophysics. And there's a big project called the Giant Magellan Telescope. Those of you who are interested in astrophysics, there's a huge project built by multiple organizations worldwide. And I'm going to go there with a group of 20 supporters who care about physics and astrophysics to visit this amazing site, but I will mention this briefly. Before I'm going to give you a few examples and focus on the vision, this one last point about a medical school. Weizmann will always, doing basic and fundamental science. Very recently, we decided that we want to open medical school. And the reason we decided to open medical school, not because Israel needs more doctors and it's fine, but it's not that. The reason is that medicine is totally changing today, okay? And we're going to talk about AI in a minute and other fields. This is a very unique program in medicine because all MD students will have to do PhD. And they will have to do the PhD before they start their clinical training. And they can decide to do the PhD in AI or in quantum physics or immunology. It's their choice. So we are going to actually start registration this year, but the idea is really to generate this cohort of physician scientists. We want to get clinicians that can really understand the problem, and we want to create scientists. Some of them will continue or remain to do mainly science, but really understand the biomedical challenges. Okay, so I want to talk briefly about the vision, okay, where we put the efforts today, where we put the resources, the money. What are the main topics of research that we think are important for the next decades? I'm sure you're going to be, it's not going to be secret. Many people and many institutions are working on those, but you should know that the Weizmann will never choose a field of research to invest if we don't already have a critical core of excellence. I mean, if you don't have very strong science in something, we will not decide to invest. Again, from the reason that we are a small country, and again, we all agree that, water are the best topic today. If we don't have the best water scientists, we're not gonna invest in this. These are sparkling, so bad choice, but it's my fault. So what are those topics that we are now investing? And I will do it, of course, we don't have time, so I will do it relatively quick. The first one is the brain. Is the brain and the nerve system, and the question is why? This is not because I'm a neuroscientist, of course, because this is the last frontier in the biomedical research. Okay, we gained a lot of knowledge in the last decade or two about the brain, but still, this is extremely complex organ. Just think about the pathologies which are associated with this organ. All the neurodegenerative diseases, Alzheimer and Parkinson and ALS and dementia. What about all the mental health domain, okay, which is my field, depression and anxiety and post-trauma and eating disorders and schizophrenia and autism? For all these, we don't really have solutions. And the idea is that, I don't know how many of you are familiar with the brain and understand the complexity, but we are dealing with around 80 to 100 billion cells in this organ. A single cell, a single nerve cell called neuron in the outer layer of your brain called cortex is connected and communicate simultaneously with 10,000 other cells. 10,000. Okay, so just think about each of you now connected with wires to 10,000 people and can tell each one in a millisecond resolution to do something else. You run left, you run right, you jump, you sit. But you have billions of these cells. So now you understand why we need people who come from computer science and math. This is a very, very complex organ. So what we're doing now, we're bringing all these experts from all the fields who care about the brain to sit together and interact. And we have more than 600 people today working on brain at the Weizmann. And it's an amazing time for science, for brain sciences and others, because technology today brought us to the level that we can do things today we couldn't do 10 years ago. Today you can sequence your DNA. You all know that in the first Human Genome Project in 2000, the first human genome cost $1 billion. Today, to sequence your genome costs $100 with much, much higher resolution. Okay? Today, the ability to look inside your brain, okay, with MRI machine or functional MRI machine in resolution, and Weizmann have an fMRI, functional MRI machine, which is a 7 Tesla, by the way, the only one in the Middle East that can get amazing resolution of the brain. So there's so many techniques today that can really allow us, with the right investment, the right people, to create new knowledge that hopefully will also bring us to new discoveries and new medications and so on. The next big topic, and I mentioned astrophysics, is the frontiers of the universe. So if the brain is the last biomedical or medical frontier, the real frontier is the universe. Just look up on the sky, and the Weizmann have amazing group of astrophysicists and particle physicists. I mentioned already Chile, but there is another project, which is our own project, which is not very common project for academic institution, but we are building, in the last few years, we are building a satellite. It's a telescope satellite. It's a very unique setup. It's a satellite, and a telescope is, although it's sitting on a satellite, it's not going to look down to Earth. It's going to look up to the universe. And the purpose of this satellite is to capture what we call transient astronomical events. You know, like supernova. Supernova, and when stars are blasted, and these blasts are considered the source of all materials in nature. But no one ever really captured this live on a telescope. Oh, you look on the maps of the stars, oh, this star was here yesterday, is not here today, so, oh, this was a supernova. So we really want to try to capture this and collect the data. So we are building this together with the Israel Space Agency, the industry, the European Space Agency, and NASA. NASA is actually going to launch this for us for free in the first quarter in 2026. So we are currently building this. But I told you it's a very wide, because these are rare events, okay? It's happening, maybe we can capture 5 or 10 of those events every year. So we really need to scan the universe in a very wide angle. If it's a wide, the resolution is going down. But then this is the reason it's a satellite, because it's a satellite, so it's connected to other ground telescopes, which are much more narrow, but very high resolution. So in a minute, our satellite, our telescope sees something, it can direct other telescopes on the ground to start and collecting this data and to make sure that it will work. And although we have a lot of telescopes on Earth, many of them will be busy at that specific moment. So we built now an array of 48 telescopes, ground telescope in the Israeli desert, really in the south, next to Eilat, when the team here visited, not far, which is a beautiful set of telescope that is connected, will be connected to this satellite. Another very, very important topic that I'm sure you, and I know Monaco have a lot of passion for this topic, and this is the environment, something that is probably the biggest challenge humanity now is facing. We are 8 billion people on this planet. It was last November. And things that we always was very trivial, like food security, is not trivial anymore. The amount of contamination and plastics, and all the way from the sea to air and others, so relating, of course, to our health. But there is many, many other issues. So Weizmann have, and this is probably the most interdisciplinary field of research. You know, every institution you go, we have 60 groups at the Weizmann working on environment and sustainability. Some of them are coming from plant biology, generating new type of crops. Others are working in marine research. We have 15 groups of research working now on marine sciences. We people coming from chemistry, getting biodegradable plastics or other technology, but physics, chemistry. This is probably the most really multidisciplinary type of research. I don't have too much time to go into example, but maybe only one example. At the Weizmann, we have one of the world leader wheat expert. You know, the original wild wheat is coming from the Middle East, okay, in the Israel area. But this wheat, which by the way is very small, have only few grains, but it's very, very resistant to drought and to disease. So what this Professor Avi Levy did and his team, they isolated from the wild wheat the genes that are responsible for resistant to drought and disease, and they transfer them into the modern wheat, which of course have a lot of yield and it's big. But now we have a very strong wheat, and with the global warming, we know that there are going to be many places on this planet, Africa and others, that are growing wheat now that will not be able to grow wheat because of the climate change. So you're already preparing a new strains of wheat, but also fruits and vegetables, which will be able to cope with this type of changes. One before last is AI, and I already mentioned it's already really changing changing our worlds quite dramatically every day. It's really changing science and the way we do science. Actually, today, there's almost no field of research. This is, by the way, type of AI. It's that is not affected by science, and the reason is very, very simple, okay? The fact that today, in every field of research, we're generating so much knowledge, so much data, that we know that we are not extracting the full knowledge which is hidden within this data. This is the reason we need to use AI. We need what we call machine learning algorithm to get more knowledge. You know, in my field of mental health, we are now have DNA of thousands of people. I can put students or big team in front of Excel file, they will never be able to see it. Okay, so AI have a very, very important role in research today. So our goal, I like to see it as an umbrella project, okay? We are spreading AI experts in every field of research, okay? That will support the science regarding its physics, chemistry, biology, cancer, brain, and so on. And I will finish with one example just from the last few days, what AI can actually do today. The last topic I'm going to mention, and then I will give you a few examples and we'll finish with this, is immunology and infectious disease. Weizmann was always very, very strong in immunology. The list of blockbuster drugs I showed you, probably 70% are coming from this domain of research. I think COVID was, for us at least, I think for humanity in general, a wake-up call how important this topic is, okay? And the Weizmann did something quite unique, I think, during COVID. When the pandemic started, 25% of Weizmann scientists, groups, started working on viruses and COVID, okay? We had immunology, but we didn't have so many people working on viruses before. And this has created huge amount of knowledge. It's also fair to say that we were lucky. You know, Israel in general was the first one to get the Pfizer vaccine. So we had the first 1 million people vaccinated by this vaccine. So we had the data. And then the second vaccine and the booster. And Weizmann scientists were the one who analyzed all this. So eventually Weizmann was the one who convinced the FDA to give the booster in the US, the European Union to give the second injection, because we had the data. So we decided this was not the last pandemic, as you all know. And I will, you know what, let me connect this to the environmental to the environment. We mentioned we have 8 billion people on this planet. We have much less natural habitat. There are currently 40,000 viruses in wild animals that can infect humans. They don't need to mutate, they just need to jump, okay? Some of them are totally fine, some of them are mild, some of them will be like COVID, some of them are gonna be much worse, okay? So the assumption is that more people, less natural habitat, more interaction, we're gonna have more this type of infections and pandemics worldwide. So we better be ready for the future. So overall, COVID, I think, did good, at least in this aspect that it was relatively mild pandemic, okay? You know, it started as around 1.5, 2% lethality, and after a year and a half, it was 0.08. Today, it's even less, which is less lethal than seasonal flu today. So you have to remember this, so it's not a pandemic anymore. Let me give you a few examples. I was struggling to we talked and said, okay, let's give you an example about science. And you know, I told you these 3,100 studies published only this year. No, of course, not all of them it's easy to explain, but I just selected few, not from the history because it's very exciting, but just from the last few months, and I will finish with this. This is one beautiful example by Professor Eran Elina. Eran is immunologist. He's actually one of the world leading scientists working on microbiome, yeah, on your bacteria, which is within your gastrointestinal tract. And he having those really amazing studies over the last decades. But just a few months ago, he showed something very unique. You know that, and it was very clear during COVID, that people who have diabetes, either type 1 or type 2 diabetes, the severity of lung infections is significantly worse. Those people, the chance that they will have infections that eventually will kill them is significantly higher, but no one really could explain why. And he found why recently. Apparently, there are very specific cells called dendritic cells. They're immune cells in your tissues, which are very, very sensitive to glucose. So when your glucose level in the circulation goes up, the function of those cells go down. So he was able to change and manipulate the activity of those cells by playing with the glucose level. It's very basic, yeah? It's a basic knowledge, but now we have a door. We have a way to go and try to interfere with this process and help people with diabetes. By the way, type 1 or type 2 is the same problem. I'll give a few examples of how basic science, really mechanistic science, can help us find solutions. This is one of the most amazing discoveries, and actually it was selected by Times Magazine as one of the top 50 discoveries of 2023, done by Professor Jacob Hanna. Jacob did something quite amazing. I don't know, it was in the public news, so I don't know how many of you saw it. It was in The Guardian for, I think, a week or two on the top. Jacob managed to build an embryo, a human embryo, without a sperm, without egg oocyte, and without a uterus. Just from stem cells, okay? So you all know what stem cell is, and you know embryonic stem cell that can differentiate to many cells, but I'm sure you also know that it's a bilateral direction. I can take now your cell, let's say your skin cells, and I can redifferentiate them to become stem cells. So they were skin cell, I'm gonna make them to be stem cell, and then I can decide, I can make them brain cells, liver cells, heart cells, and so on. This is Nobel Prize, by the way, Takayama, more than 10 years ago, I think, the concept. So, but what Jacob managed to do here, actually when he came to me 3 years ago, he said, I need $6 million and I can do it. I said, go, it's a science fiction. Although I should not say this, yeah, it doesn't seem real. But it's quite amazing. Initially, he showed this with mice, but people say, okay, it's mice. And now, a few months ago, he did it with humans. Of course, he stopped it in around 2 weeks, but you still have already a beating heart, and you have the main organs, even start development of the nerve system and the brain. But it's not that we necessarily need this in order to create babies from one sex. Okay? Men, don't worry. We still have a role in this world, maybe. It's more about understanding the early development. And just think about the consequences. Let's say I want to create organs today for transplantation. What's the problem we have with transplantation? It's mainly rejection. And the waiting list, I need new heart, I need new liver, I need new kidney. Okay, it's a waiting list, and then I'm getting something, and my body is rejecting it. But if I know the process, and I can take your own cells, redifferentiate them, and make for you a liver, a heart, kidney, maybe one day a brain. By the way, we can do brain, but we don't know how to connect it yet, okay? We're gonna have spare parts. So the technology is already there. There's at least 2 or 3 companies today. Oh, this is what they do, okay? And this is type of science is really creating jump in knowledge that eventually affect our health. I need to ramp up, yeah? Very quickly. I don't know if you recognize Professor Ada or not. She is a Nobel Prize in chemistry from 2009. She was the one who solved the structure of the ribosome. Ribosome is a very, very complex. Show them it's a very, very complex protein, protein complex. which is the machine. It's a factory of the cells that make proteins in the cell, okay? She worked on it for 30 or 40 years, but what she did very recently, she took a parasite which is causing the sleeping sickness. You know, it's mainly in Africa. 40,000 people die from sleeping sickness every year. And she managed to go to the ribosome of this parasite and block it in a way it cannot make its protein. So even if it's infecting you, the parasite, it cannot make its own protein and eventually cause the disease. I'm doing it very, very brief. Another amazing guy. You're going to hear about this guy for the next few decades, Professor Rotem Sorek. He's a microbiologist. And you know what he's studying? He's studying the immune system of bacteria. You say, who cares about the immune system of bacteria? I don't know if you know, but bacteria are infected by viruses. They're called phages. You see these strange creatures? Those are called phages. Those are viruses that infect bacteria. Very, very common. By studying the immune system of bacteria, Rotem identified more than 100 immune mechanisms. Interestingly, some of those immune mechanisms also exist in humans after he found them in bacteria. So why it's interesting? Because if we understand how bacteria protect itself from viruses, we now can create new type of antibiotics because we can use this knowledge to eventually fight bacteria, how to overcome its immune system and attack this. All the future, and you know, we have huge issues with antibiotics today, with bacteria which are resistant. So this is the new era of antibiotics. Two more and I will finish. Just another beautiful example from Moran Shalev Ben-Ami, and she's also a structural biologist, you see, or these structures of protein. She actually grew up with Ada Yonat, but she's working on a very unique protein in the brain, which eventually determine how much you eat and the feeling of satiety, meaning how much full you are, or the feeling of being full or hungry. And it's quite unique because some people have mutation in this receptor and they just like to eat more and more. And this, of course, can cause type 2 metabolic syndrome and obesity and so on. And by solving the structure of this and identify where a molecule can bind, she actually generate the knowledge to create eventually a new treatment, a new drug for obesity and metabolic syndrome. I will skip this one just because of sake of time, and I want to share with you this last one, which is AI. I showed you mainly biomedical, and this is amazing study from Tali Dekel. She's a professor at she's coming from math and computer science. She's an AI person, but she's also working on computer vision, okay? And I'm sure all of you, played with ChatGPT recently, and you even know that today there's a lot of programs and you can type a text. You want to take the example I took today, Monaco in snow and Christmas time with jumping fish. And you are going to get a photo, okay? And you create something, a text, but this is an image, a photo. Those of you who saw the news yesterday or 2 days ago, OpenAI showed something which is very similar to what I'm going to show you today. And this is taking text and making video. You type a text, any type of text, and you create a video. So I'm going to show you this short and with the permission from Tali and Google. It's 1 minute or so. This is all AI generated, okay? This is not real. And he's explaining how this is done very briefly. I know it's a bit fast for the text, but I want you to, in a minute, you'll see that, to appreciate the flexibility of this. This is a little bit explaining how this is done, but how the algorithm is working. But what they can do today is this is just unbelievable. Look on the smoke. You want to change the dress? Just tell him which dress you want. In a movie, in a video. Okay, I want this lady to be a flower. I want this lady to be a wooden block. I want this lady to be origami or... So the flexibility. Just think about the cinema industry and actors, what they will do next year when this technology gonna be... So this is just coming very soon, and this is collaboration of Tali Dekel together with Google. Tali is an amazing scientist. 1 day a week she worked with Google to develop this type of research, and OpenAI just released this. Go into the news, you will see it yesterday. So 2 big companies which are dealing with this. So I can talk for hours. I will stop here, and I really will appreciate and be happy to answer any question. French is fine because I also have this, so I can answer all questions. So thank you very much for your attention. And, Okay, questions? Yes, please. Just tell me if English or French, and then I will know whether I need to put this. You know, my parents spoke fluent French, but it was the secret language between them. They always talk very, I was not supposed to hear. It's very different from today, yeah? So I never learned properly. Yes? French, okay.
Est-ce que si on injecte des cellules souches à une personne malade, elle peut être restaurée et guérir complètement?
Fantastic question. So the question was about if we take stem cell and inject them to a sick person. First, depending on the pathology, okay, what is the disease? But this was a very, very hot topic for many years. Let's take, for example, Parkinson's. We know exactly what's happening in Parkinson, okay? We know which nerve cells in the brain and where are dying, okay? It's called cells that make dopamine, which is a very important neurotransmitter. And as long as those cells are slowly dying, you have more and more severe pathology. Today in the lab, we know to take stem cells. We know how to make out of them nerve cells that make dopamine. We know how to inject them because we know exactly where. But we still don't have this treatment today. And there's only one reason, and there are multiple companies who are doing this, is because the FDA and other regulatory agencies are requiring that we will know 100% that all the cells that we eventually injecting are differentiated, meaning they are not stem cells anymore because they are already nerve cells. And the reason is very simple. Stem cells have this ability to proliferate very, very fast. You know, they are dividing, and if you have only one cell out of millions that is still a stem cell, very fast you're going to create a tumor. Okay? So the same with the same studies about type 1 diabetes, cells that can create beta cells that make insulin. It's in the research, meaning there's fantastic research done all over the world with this, and I think eventually it will come. So it's not only creating from embryos, but using stem cells to treat diseases that eventually are caused by death of cells from different types. Just to see you better, yeah.
Est-ce qu'on peut...
Just a minute. Okay. Yes.
En cas de maladie du sang, et presque pour des personnes avec des cancers généralisés, est-ce que les cellules souches ne sont pas une solution? Est-ce qu'on peut injecter les cellules souches à la personne et elle revient complètement à la vie et complètement à la santé. Est-ce que c'est une solution?
So cancer is much more complex pathology. Okay, there's many type of cancers. Yeah, and most of them are not caused by cells which are dying. Actually, by exact opposite, cells which lost control over proliferation. So this will not be a good solution for many of the cancer currently. But cancer research made such a huge jump over the last 2 decades that the prediction is that most of the cancer will become a chronic disease in the next decade. People will not die, and it's a big statement, yeah? With the majority of cancer, there's many of the cancers today, there is more than 95% recovery. So I really hope, I always tell people that I hope with the brain disease, neurodegenerative diseases and other mental health diseases, if in 10 or 20 years we will be where cancer is today, it will be amazing success. Cancer is, because of huge investment, by the way. I didn't talk about Weizmann cancer, but we have 50 groups doing cancer, huge success. Marco's family, Dweck family supported this for many years, and the Weizmann with a very big success. There is a question there at the end. Also, you decide, please, yeah.
Thank you very much. Thank you very much, Professor Chan, for this very nice presentation that you have made. My question is not on science, it's a bit more on funds. Because your excellence, you can have excellent scientists, excellence in science. You apply for the European grants, but I don't believe that are covering your expenses. And I'm really very glad if you can explain a bit how you got your sponsorization for funds. Thank you very much.
Thank you. Okay, so I didn't talk about how we fund the Weizmann, and we are not university, so. And I told you that we are non-profit, so how we manage this big, and I mentioned 5 topics. We're going to invest $2 billion in the next 7 years in those topics, and so I will tell you the numbers. So 20% is coming from the government, 20. Universities in Israel usually will have tuition, and government is 80% or 20%. The biggest portion of our budget, which is 40%, is coming from our endowment, which was generated mainly from patent revenues. Okay, again, we are non-profit, it's not our aim, but some of the knowledge we generate create income. 60% of this income is going back to a saving that go back to the institute, and 40% goes to the scientist, which is very large, you know. Many of those scientists that develop those eventually add also a lot of income. So this is 60%. Another 30% is coming directly from our scientists. I mentioned the EU, but there's also other, Israel Science Foundation. So this is a very large portion the scientists bring themselves. And the last 10% is philanthropy. Philanthropy is still very important at the Weizmann. So yeah, this is the operational budget. When we're dealing with development, meaning new building, new infrastructure, major equipment, the government in Israel gives 0. I think they have more important things to do, unfortunately. And so this is around 70% philanthropy. This is the reason you come and visit, and I hope I at least convince you to come and visit, because it's really a unique place. And then you will see a lot of names, because this is supported mainly from philanthropy, and around 30% is from internal resources and so on. Thank you. Yes, there.
Hello. My question is regarding artificial intelligence. With this text-to-image and text-to-video, where is the intellectual property? Is it with the
fantastic
prompter
question.
or is it with the video?
It's a fantastic question. So, you know, it's very unique because we're always very concerned about it. So this is with Google, and we have scientists who work with Meta and Microsoft, and the AI is progressing so fast that there is almost no IP, no intellectual property. A lot of it is a know-how, and those algorithms, it's really hard to eventually... I'm not saying there's not IP at all, but it's such a fast-growing field, and it's so competitive with so many companies. Look on ChatGPT. Eventually, everyone can use it. If you want to get the more extra version, the complicated one, so you pay $50 a month. So, but tens of millions or many billion of people are going to use it. So this is going to be an income. It's actually happening right now. It's a very important question, because actually I was talking to the vice president of Meta 2 weeks ago exactly about this, because our scientists are working with them. I said, okay, how I know what you... She said, most of it is not patented. Most of it is what we call open resource, open access. It's not patented, which is beautiful, but it's such an important topic. There's a lot of ethical issues, and so many, it has to be controlled. And the problem is that the technology is now coming before the regulations. No one is, there's all kind of committees, but there's no clear guidelines. Where is the border? I mean, you can take now my lecture, and it's broadcast, it's videoed, and you can totally change it. You can put things that are never said, and it will look perfect. So how you need to distinguish between fake and real, how it's going to shape politics today. Anyway, it's crazy out there now. We are, it's hard even to imagine. What will happen with autonomic cars? I don't know if those of you, your car is already a bit autonomic, but I drove a few months ago with fully autonomic car in Israel. Company called Mobileye, one of the first one. It's an amazing guy, scientist from Israel, Amnon Shashua. And I was driving with this car inside Jerusalem and on the highway from Jerusalem to Tel Aviv. Initially, we were very worried, but this is unbelievable. Meaning, it's even socially adapted. Israeli are a bit aggressive in driving. It's like Italian, yeah. The car behaves the same. The car is adapted to the style of driving. And suddenly someone is coming in front of you inside the narrow street, you will move aside. And maybe, after all the cars will be autonomic, and this is Professor Shashua Amnon told me, the car just decide they prefer not to drive you. They will just stop all of them together, and they will ask you to leave the car, and they will just go and will just drive. It seems crazy, but this could happen if we don't really control it. It's fascinating. Maybe the next lecture you bring some AI expert. I can recommend someone, because it's really going to change our life, okay? Think about medicine. You're going to go now to the doctor. As much as we have talented clinicians, physicians, the computer, will do a better job, because it can integrate your genome, your epigenome, all your lab tests 50 years back. And it can recognize things that, with all due respect to the best clinicians, they cannot integrate all this information. So ideally, a good clinician in a few years will have a computer next to him. We need the human interface, yeah? It's good, it's nice. Unless we're going to have robots, which are going to be exactly like humans, but let's wait. It's going to be critical. All of us would love, I think so, I'm not sure, to know what our genome is telling us. Maybe in 10 years I will develop cancer or Alzheimer, if I want to know and don't want to know, maybe. So AI totally gonna change the way we live. Good and bad, yes. There is...
This will be our last question.
Okay. We're gonna have a cocktail, so I'm happy to continue answering questions and...
Yes, hello. I'll try to make it inspiring for everyone since it's the last question.
Okay.
As we see all these scientific developments and progress, we cannot not ask ourselves what are the implications and what is the impact on education for the younger generations. How can we change things also? Maybe not as fast as it's growing in the science, but just make things evolve together thank you.
Thank you. I think it's a fantastic question. If you ask me, as a scientist and someone who really care about science education, I'm doing this I'm the chair of the Weizmann Institute. I'm doing science education since I was very young. I think the solution for most of the problem, if not many of all problems, including political questions, eventually is education. And I think Israel and the surrounding country is a beautiful example. Eventually, if you can educate people, if you can really explore them, give them the opportunity, give them the access to proper education, internet, source, I think it will lead to a much better, I'm trying not to go into politics, but it can lead to a much more peaceful and inclusive society. And there's a strong correlation if you just look on educated populations. You know, in Israel, 80% of the people go to university, 80%. And look on surrounding country, look on the education system. And I'm sorry I didn't plan to go politics, but eventually what you teach your kids, if you teach your kids only about peace and they grow up with this, or you teach your kids that it's okay to kill Jewish people or push them to the sea, eventually it filters. And it will take generation to fix. But this is the only way for the long term. And the public, I think, understand this, you as adults, but children need to understand the solutions for human challenges, for humanity challenges, environment, health, will only come from science. You know, we don't know, and I'm sure all of you are familiar with the big project in CERN, the accelerator. Weizmann have a very important role in this. We are building the detectors at Weizmann, and they are shipped here, and we have many groups of people. These are 60 countries, thousands of scientists from all over the world. People say, why it's important? Why it's important now to look on supernovas? Why we need to build a telescope that costs $2 billion? We don't know why. But you know that without CERN, you wouldn't have internet. Internet was invented in CERN just because they needed a way to communicate between the 6,000 scientists. The same with MRI machine. MRI machine was not invented because they needed, it was invented from totally different reasons. So maybe you don't understand now why we need to look on supernovas and the stars, but maybe in 20 or 30, 40 years, we're going to get new source of energy or new materials that can solve problems and so on. Doesn't mean that science cannot be harmful. Look on nuclear power and nuclear and so on, but you cannot stop progress and you cannot stop science. You can regulate science and progress, and this have to be done now with AI that we talked, but just look through history. People live longer, people are healthier. Despite the wars and the concern, we do live in a more peaceful, hopefully it will stay like this, planet. So thank you for the question. Thank you everyone for your attention, and I will be happy to answer questions in person. Thank you.
Messieurs, dames, avant de rejoindre le cocktail dans la salle du fond, je vous invite à déposer vos traducteurs sur vos sièges, s'il vous plaît. Merci.